Today's lecture is about rotational dynamics. Recently, we talked about Newton's laws. That was all about linear dynamics. Basically, when there is an object and you want to exert a force on that object to displace it, the result is, according to Newton's second law, the net force, which is the sum of the forces, equal ma. Today we're going to look at objects that have tendency to rotate. A typical example is a door. If you look here, right here, that's a door. It's a look from the top. Here's the knob on the side. Right here, you're going to find the hinges, one underneath the other. So what do you do to open a door? You need to apply a force, right? When you apply a force, the door can swing this way or swing the other way. It depends how the door is set up. In order to open the door, you need to apply force, right? Let's say somebody goes to this door and applies a force in the following direction, right? This way. Do you think that person will be able to open the door? Clearly, the answer is no. We will have to explain in a minute why this force is not capable of opening the door. How about somebody trying to open the door, going right where the hinges are, right here, and push on the hinges with the force F? Do you think that person will be able to open the door? Of course, the answer is no. We have tendency to place knobs all the way at the end, right? And how do we apply forces in general to open doors in an easy way? We apply forces in a perpendicular form, like this force here. So the force will go like that. Notice that in order to rotate objects, you need a force, and that force needs to be applied at a given point in a given direction to obtain a good result. That combination of a force and where to apply the force and how you apply the force is known as the torque. To rotate object, you don't need a certain amount of force. Instead, you need a certain amount of torque. We use the Greek letter tau to describe it, and it's equal to force times lever arm. This is the part that is kind of new to us, the lever arm. We need to get used to it. We need to understand what it means. In order for me to explain, I'm going to use the following figure to explain what the lever arm is all about. Okay, let us try to apply a force, not necessarily perpendicular. That will help us explain the lever arm a little bit better. So the force that I am going to apply to this door is the one that is pointing along this direction right here. Okay, so this is my force right here. The dashed line, this one here, is known as the line of action. The line of action is the line along which the force is acting. So basically the force is acting this way along that same direction is the line of action. Very easy to find the line of actions. That's one information that we need. The other information that we need is the axis of rotation. In this particular case, it's very easy to identify the axis of rotation to be where the hinges are. It's a line that is going through the 2 or 3 hinges mounted to the door. Okay, now I'm ready to define that lever arm. The lever arm is the shortest distance from the axis of rotation, which is this, to the line of action. How do we make the shortest distance? Very easy. You just make a line, and that line needs to hit the line of action in a perpendicular form, making a 90-degree angle. So this red dashed line is indeed the lever arm. So the torque is equal to the force applied to the end of the door times the lever arm, which is this dashed line here. how do we usually evaluate the lever arms? You use the size of the object, in this case the width of the door, the angle made between the force and the door. The lever arm we just talked about always make a 90-degree angle, so you're going to end up with right triangles all the time. Use your trigonometry skills to evaluate the lever arm, which is this dashed line known as the shortest distance from the axis of rotation to the line of action. Alright, based on what we said here, we go into face many questions in which the torque becomes an important component to solve these questions.